schienzosa, quando siete disturbati, troppa rock and roll.
Sorry, boys and girls. I was just running up the Leaning Tower of Pisa. Alright, welcome back to your presentation on graphing inequalities. I just got done hiking up the Leaning Tower of Pisa, which we'll talk about in a minute. But our learning target for this presentation is being able to differentiate between an open and closed dot and to graph an inequality on a number line. So let's go back to our Leaning Tower of Pisa. At most, the Leaning Tower of Pisa has 251 stairs. At most means that I can hike up 251 stairs, but that's the most amount of stairs that I can hike up. I can hike up 30 stairs, I can hike up 150 stairs, I can sit at the bottom and take touristy pictures and not hike up any stairs, but at most it has 251 stairs. So if I were to graph this on a number line, at most 251. If I were to graph this on a number line, I could start at 251. Next comes 252. And 250 comes right before 251. Now, I'm going to use a closed dot at 251 because I can actually hike up 251 stairs. Do I have to? No. I could hike up 250 stairs, 249, 48, 47, 46, so on and so forth. But at most, I can hike up 251 stairs. Now let's talk a little bit more about graphing inequalities. Graphing inequalities, there's three parts. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution set, and the set of all solutions inequality, or all of the answers, are called a solution set. Let's look at a few examples. Before we look at the examples, I want to talk about the difference between an open and a closed dot. An open dot is used when a number is not part of the solution. A closed dot is used when a number is part of the solution. So in our first example, what I like to do is read the inequality out loud, or to myself. G is greater than 2. If you're unsure of how to read the symbols, you can refer back to the last video or your graphic organizer. So G has to be greater than 2. I'm going to leave an open dot at 2 because I can't include 2. G has to be greater than 2. So what numbers are greater than 2? 3, 4, 5, so on and so forth. So I'm going to shade all of the numbers that make the most sense, or all of the numbers that go in the greater direction. Let's look at another example. N is greater than or equal to. That line underneath symbolizes that N can also be equal to the other number. So in this case, it would read N is greater than or equal to 8. I'm going to use a closed dot at 8 and shade all the numbers that are greater than 8. So 9, 10, 11, so on and so forth. So all of these numbers are greater than or equal to 8. Again, I can include 8. As a strategy, if you want, you can highlight underneath when we have that or equal to, have yourself remember to shade a closed dot. All right, let's look at another example. This example tends to get a little confusing for students, but I want to show you anyway. The difference with this inequality is that our number comes first. This would read 3 is greater than or equal to x. So I'm going to shade a closed dot at 3, and 3 has to be greater than all of the other numbers, which was represented by x. So 3 is greater than 2, 1, 0, so on and so forth. Some students like to rewrite it as x. I'm going to switch my inequality symbol because I'm rewriting it backwards, is less than or equal to 3. And it still works. I'm going to have my closed dot at 3, and all of these numbers are less than 3. Okay, let's look at one more example. M is greater than 5. I'm going to leave an open dot at 5 because M is negative 5. Just so you guys know, this is the third time I'm doing this presentation because I've actually deleted it accidentally twice. Go me. Alright, so I'm going to have an open dot at negative 5 because M can't include negative 5, but it's greater than negative 5. So that includes all of the numbers, even in between each whole number. So this could be negative 4.5, negative 4, 1.5. Every single number is included on the number line, even the ones in between each whole number. Okay, what I want you to do is get out your graphic organizer. And we're going to do a few examples. Let's start out with x is less than 2. I'm going to leave an open dot at 2 and shade in the less than direction, where all of the numbers that are less than 2. In our next example, less than or equal to. Or equal to. Let's use C is less than or equal to, I need the line underneath, negative 6. So I'm going to have a closed dot at negative 6, and again, shade in the negative direction, or shade all of the numbers that are less than negative 6. In our next example, we're going to use greater than. So let's use Z is greater than 1. I'm going to leave an open dot at 1, and now I'm going to shade in the greater than direction, or all of the numbers that are greater than 1. Our next one is greater than or equal to. Again, that or equal to symbolizes I have to include that number or put the line underneath. Let's use H is greater than or equal to 3. So I'm going to have a closed dot at 3 and shade all of the numbers that are greater than 3, which is 4, 5, 6, 6.5, 6.6. Now the last one's a little different. Not equal to. So let's use F for Fosdick, the #1 math teacher in the world. So not equal to means that F can be any number but the one that's given. Let's just use 0. So the letter F can be every single number but 0. So because of that, I need an open dot at 0 And I'm going to shade in both directions because f can be every single number but 0. And then I'm going to go back and highlight 1 because I'm number 1. Okay. Again, if you want to go back and re-watch each of these so you can hear it again, but coming to class tomorrow with any questions that you might have, and we're going to work on continuing to graph our inequalities. All right, I'm going to go have some pasta and go hang out in Italy. See you guys, have fun. I know you're still watching. You love this video, don't you? And this music. Ciao!